Let's look at Edx M2 Jun 2011 question 8. The question is on the topic of projectiles, and here's the question. Pause the video and take a while to read the question so that you're clear what it's about. Right, assuming you've done that. The first part of the question, I've taken the liberty of writing this out because it's standard bookwork, and you've probably seen this before. You should have seen this before, I would think. Basically, you need to write the equations of motion either in vector form, or you might prefer to write them as separate horizontal and vertical equations for the velocity components and the x and y displacement. I tend to use vectors. So, picking out the x displacement, we've got here x is u cos alpha t, and the y displacement goes y equals u sine alpha t minus 4.9 t squared. Now, to get the equation they want, this equation here, all you have to do is eliminate t by substituting the t in from the x equation, so t is x over u cos alpha, and put that into the y equation. And then it drops out because sine alpha over cos alpha gives you tan alpha. The u's cancel. Oh, they've used, instead of 4.9, they've written g over 2. So practice that because it's easy marks if it comes up. Let's go on to the second part of the question. In the second part of the question, they talk about a girl throwing a ball off the top of a cliff from a point A. Now, this sort of question, you've just got to be careful with your x and y's, because assuming that the origin is here at the point of projection, which is what our equation from part 1 was assuming, we have to think now about where this ball is going to be in terms of that origin. So read the question. A is 8 meters above a horizontal beach. What you have to do is find the horizontal distance of the ball when it's 1 meter above the beach here. So that means that it's 7 meters below O. So what we've got is x is unknown, we'll call it x, and the y is minus 7, and u is 7 and alpha is 45 for this bit. So we can use the equation from the first part and simply put y in as minus 7 equals x tan 45 minus 9.8 x squared over twice times 7 squared, which is 49, times cos squared 45. So everything there we know apart from the x, and what happens with that is it turns into a fairly straightforward equation, a quadratic equation, which is 7 minus 7 is x minus 0.2 x squared. That's what that equation becomes when you put all the numbers in. And when you tidy that up and make it a bit more user-friendly as a quadratic, you get 2x squared minus 10x minus 70 equals 0. You can divide by 2 there. So let's do that. So x squared minus 5x minus 35 equals 0. Use your calculator if it's got a quadratic solving function, or use the quadratic formula if it hasn't. So there's a few steps that I'm not going to put on this video. You solve that equation and get x equals 8.92. That's the only positive answer. So x is 8.92 meters, and that's that bit done. One more bit to do. And for this part of the question, it talks about a boy standing on the beach at a point B vertically below A. So the boy is standing here, and he starts to run in a straight line with speed v, so he's going to run along here, leaving B 0.4 seconds after the ball is thrown, and catching the ball at this point here. Find the value of v, the speed he runs at. So we know that x is 7 cos 45 times t in this case. So we can find the time it takes the ball to travel horizontally to the point C at 1 meter above the ground, because we know the distance is 8.92 from the second part of the question. So if you just calculate t from that, you get t is 1.8. So if t is 1.8, the boy travels for 1.4 seconds, because he doesn't start running until 0.4 seconds after the ball is thrown. You can see where we're going with this now. We're trying to find the speed of the boy, this v there. He's got to travel 8.92 meters in 1.4 seconds. So a simple calculation to find v. Turns out to be 6.36 or 6.4 meters per second. And that's that done. So looking at the marks for the different parts of the question, too far. The marks for the first part, the standard bookwork, there were 4 marks for it. There was a B1 mark for seeing that x equals u cos alpha t, and a single mark as well for seeing y for this one. And then for substituting in t, for t from the x into the y, there was a method mark and then an accuracy mark, M1A1, for doing that properly. There's the 4 marks for the first part of the question. Then for this second part of the question, we've got 5 marks for this. There was an M1 and an A1 for substituting y is minus 7 and putting all the numbers into this equation. And then there was 2 method marks for carrying out the steps to solve the quadratic, and an accuracy mark for getting the right answer. And that gives you the 5 marks for that part of the question. Those 2 method marks there are for the process of going from the original expression with tan 45 and so on in, and getting the final answer. For the third part of the question, four marks for this. There was for using the horizontal equation of motion, there was an M1 and an A1, and then for using the right time, subtracting 0.4, and for doing this calculation to find velocity, another M1A1. So that's it. Thank you for listening. Let's just leave you with this last slide, which tells you more about further math support program.